No, not this. Anything but this. We have homework assignments. No. Hey Wildcats, so today we're going to be looking at the 2.1 homework assignment that is graphing absolute value functions. So we're going to just go ahead and hop right into it, very similar to our previous homework equations. So let's take a look and see what we've got. This says predict what the graph of the function g of x equals 7 x minus 4 will 7 times the absolute value of x minus 4 will look like, then select the graph of the function. So we know that they're asking about how it's shifted, and if we look at this, we see that we have a negative 4 on the inside. So it is shifted 4 units, and because it is inside, we know that that is left, right, and because it's negative, we know that that sounds like left, but because it's on the inside of the parentheses, it's backwards what we think. So negative is going to be to the right. So we're shifted 4 units to the right. And then, because this is on the outside of the symbol, we know that's vertical. And they're telling us it is a vertical stretch, and it's by a factor of 7. So we need to find an absolute value graph, which we know looks like this. And we need it to be shifted 4 units to the left, 4 units to the right, and it needs to be stretched all nice and vertically. To me, that looks like D. Bam, we're awesome. Next question. Predict what the graph of this function will look like, and then select the graph of the function. Okay, well, just like before, we have plus 5 on the inside of our equation. Remember, horizontal shifts are always going to come first. So that is 5 units. This is plus, so that tells us that's going to be to the left. It is then, we have multiplication on the outside, and that multiplication is by a number larger than 1. So we know that is a vertical stretch by a factor of 3. We have a negative sign on the outside. That tells us it's going to be shifted or reflected vertically, so that's our x-axis. And then shifted, we have addition on the outside. That tells us 2 units up. So what we're looking for is, once again, its absolute value. So here's our absolute value. And we're going 1, 2, 3, 4, 5 units left, 1, 2 units up. Reflected across the x-axis, so opening down, and it is stretched. So a nice narrow guy right here. And it looks like B is the only one that is above the y-axis to the left of the, above the x-axis to the left of the y-axis. And opening down. Perfect. Next. Predict what the graph of the function g of x equals 9 over 7 x minus 5 plus 3 will look like, then select the graph of the function. Okay, so first of all, we have a horizontal shift, 5 units to the right. And secondly, we have to remember we've got a fraction on the inside. Our fraction is 9 over 7. 9 over 7 is bigger than 1. So since it's bigger than 1, that tells us it's a compression. Because it's on the inside, it's opposite what we think. So we have a horizontal compression. It's horizontal because it's on the inside of the symbol being the absolute value sign. It's a compression because it's bigger than 1, and the factor is always going to be the reciprocal of what they give us. So that's that guy. So that horizontal compression comes first. Then we are going to shift it 5 units to the right. Remember, subtraction is to the right when you're on the inside. And 3 units up. So this is a horizontal compression. A horizontal compression means we should push it in this way, so a horizontal compression is the same as a vertical stretch. So our graph should go from looking like this. We're going to move it 5 units to the right, 3 units up, so right here, and it should be narrower. Looks like it's going to be C. Alright, once again we have a horizontal transformation, and once again it's on the inside, but this time it's less than 1, so that tells us it's going to be a horizontal stretch. And again, since we've got 4 over 7 and it's on the inside, our factor is the reciprocal, 7 over 4. Minus 5 tells us we're moving 5 units to the right. Plus 2 tells us 2 units up. So if this is our absolute value, we're going 1, 2, 3, 4, 5, 1, 2. Here's our vertex. And this is a horizontal stretch, so pulling them apart, it should be fatter than otherwise. And this is our only possibility, because we do not have a reflection. Alright, number 5. Select the graph of the function f of x equals 4/9 times the absolute value of x minus 7 plus 2, and identify the domain and range. So now they want the domain and range. So in this case, we are moving, here's our absolute value. We're moving, it looks like 7 units to the right. 1, 2, 3, 4, 5, 6, 7. We are moving 2 units up. 1, 2. And then we are going to be multiplying by 4/9 on the outside, so that is a vertical transformation, and it's going to be a stretch. Sorry, a vertical compression. So we're going to compress it down, make it shorter and fatter. So we're looking for a graph that looks like that. And to me, this is the only one that fits. Let's double check to make sure they've got the right domain and range though. We know that all absolute value graphs have a domain of all real numbers. And in this case, y is greater than 2 would mean that every value from 2 up works. And we can see that the picture of the graph we drew, that is indeed accurate. Alright, once again we're doing an identify domain and range. Here's our graph. We are moving 4 units to the right. 2, 3, 4. And after we move 4 units to the right, we are going to vertically stretch it. 5/2 is bigger than 1. And then reflect it. So we need to open down and be a stretch, vertical. So it should look something like that. And here we have it. Y is less than or equal to 0. So yeah, all numbers 0 and smaller work. So C. Number 7. Same general question, except this time we have a horizontal change on the inside. Alright, so first things first, we are going to move 4 units to the right. Then we have 7/9 is the number we're multiplying by on the inside. That is smaller than 1. So that tells us, since it's smaller than 1, it is a stretch. It is a horizontal stretch this way. So we're looking for a fatter graph. After that, we're going to move down 8. So we're looking for a vertex here, and no reflections, and it's going to be kind of fat. So here is 4, -8, which is what we are looking for. But this one's also at 4, -8. This one, however, is a vertical stretch. This one is a vertical compression. We are looking for a horizontal stretch, which is the same as a vertical compression. Y is greater than or equal to -8. So all numbers -8 and up. Looks accurate to me. Same exact question again, but this time we are still on the inside with this fraction. So we are going to be a horizontal and that number is smaller than 1, so it's a horizontal stretch. But first we have to shift it 3 to the right. So 1, 2, 3, there's our vertex. And no other transformation, so a horizontal stretch comes out this way, so short, fat, opening up. Y is greater than or equal to 0. All numbers 0 and up work. Alright, select the graph for the given function and identify the domain and range. So, first things first, we have a horizontal reflection. So that's going to be a reflection over the y-axis. I may be doing this in the wrong order, so you guys may get to see me make a mistake here. Let's find out though. So, I am seeing -7/3. 7/3 is bigger than 1, which means this is a horizontal compression or a vertical stretch. So it's a horizontal compression, and then we flip it, but that does nothing, and then we add 4, which moves it to the left. So, and then 5 down. So 1, 2, 3, 4, that's from the -4, or from the +4. 1, 2, 3, 4, 5. And we said that this is a horizontal, bigger than 1, so it's a horizontal compression, which means it should be fatter, still opening up. So it should be this, and it is. So keep in mind your order of operations. We are inside the symbol here, so we do our multiplication first. That means this reflection happens before we do the horizontal shift. That's very important, because if I did the shift first and then reflected it, I would have ended up on the wrong side of the graph. I would have ended up over here on D. Alright, number 10. Oh, they want us to identify them. Okay. So, given the graph of the absolute value function below, write the function in the form g of x equals absolute value 1 over b times x minus h plus k. So, I'm actually going to do this a little funky. I'm going to say I've got g of x equals absolute value. I'm just going to put b, x minus h plus k. Here's why I'm going to do that. First step, find our vertex. We are 7 to the left and 3 up. So h is -7, so we have g of x equals absolute value of b times x minus -7. Minus -7 is +7. And then our k value is +3. Now I'm going to come over here and I'm going to find a second point that works. I see -6 and 6. So what I'm going to do is I'm going to replace g of x. That's the same thing as saying y. So now with my second point, I am going to plug in -6 for x and 6 for y. So I have 6 equals absolute value of b times -6 plus 7 plus 3. If I add these together, I have 6 equals absolute value of b. -6 plus 7 is just 1 plus 3. Subtract 3, I get 3 equals b times 1 is just b. So I get 3 equals the absolute value of b, meaning b is either, remember absolute value means just get rid of the negative sign. So that means my b is either 3 or -3. However, it's irrelevant which. Since they don't have a negative sign out front, we're just going to say absolute value, our b is 3, so absolute value of 3 times x plus 7 close our absolute value sign, and then our k was plus 3. So g of x equals the absolute value of 3 times x plus 7 close parenthesis plus 3. Notice I could have put 1 over b here, but then I would have ended up with a fraction for b as my answer, and I would have had to have flipped it anyways when I put it in here. It's so much easier to just think of it as b instead of 1 over b. Alright. This time they've gone a little bit easier for us. They want the absolute value function given in the form of a times the absolute value of x minus h plus k. We can do the exact same thing. However, when it's a that they want out front, I'm going to show you guys a trick, my preferred way to calculate a. So we know that g of x equals a absolute value x minus h absolute value plus k. Our h and our k are just our vertex points. So we have 5, 5. We moved 5 to the right and 5 up. So that's g of x equals a absolute value of x minus 5 absolute value plus 5. There are two ways to solve this from here. The textbook way is what we just did on the previous problem. You take another value that you can find that's easy. Looks like x equals 0 and y equals 2 would be an easy one to use if you wanted to solve it that way. Or I'm going to show you guys the other way that I learned how to solve this. There is a formula for a, and that formula is y2 minus y1 over x2 minus x1. That is our formula for slope back in the good old days of Algebra 1. However, in Algebra 2, we have to use whatever the parent function is on the bottom. So our parent function is absolute value. So we're actually going to have an absolute value sign on the bottom. We'll be doing this more in the future with all the different equations. But for now, we can just leave it at this. And I still think that we should use our vertex, which was 5, 5. And we should use our other point, which was 0, 2. I'm going to call this point 1. I'll call this point 2. So y2 is 2. y1 is 5, so 2 minus 5 over the absolute value. x2 is 0, x1 is 5. Okay, 2 minus 5 is negative 3. 0 minus 5 is negative 5, so I have negative 3 over the absolute value of negative 5. We know that absolute value just goes away, so we have negative 3 over 5. And let's decide if that makes sense. That is our value for A, so on the outside, that would suggest that we have a vertical reflection, so that we should be opening down. And this graph does, in fact, open down. So what we have then is g of x equals A, which is we just solved as negative 3/5, times the absolute value of x minus h was 5, plus k, which was also 5. So g of x equals negative parenthesis 3 over 5 absolute value of x minus 5. Oh, somehow I managed to get myself out of the absolute value sign. The absolute value of parentheses x minus 5, close parentheses, get outside of the absolute value sign, plus 5. So negative 3/5, absolute value x minus 5, close, plus 5. I'm actually going to go ahead and get rid of these parentheses here because the problem up top does not have it, and it may make it tell us we're wrong if I include it. Alright, number 12. Oh, here we've got our SAT style word problems. I know how much you guys absolutely love these. So, a rainstorm begins as a drizzle, builds up to a heavy rain, then drops back to a drizzle. The rate r in inches per hour at which it rains is given by a function r equals, and they give us this formula, where t is time in hours. Select the graph of the function to determine for how long it rains and when the rain is the hardest. Okay. So we know that if we've got minus 2 as the horizontal, then we're going to be going 2 to the right. And if we have plus 5 as our vertical shift, we're going to be going up 0.5. This negative 0.25 out front tells us we're opening down, and it's a vertical compression. So the only one that I see that opens down and is shifted to the right and up is C. And that tells us that it rains for a total of, looks like we get down to 0 at 4, so it rains for a total of 4 hours. And it's raining hardest here at 2 hours. Perfect. Looks like we got a little bit of billiards. While playing pool, a player tries to shoot the 8 ball into the corner pocket as shown. Imagine that a coordinate grid is placed over the pool table with its origin at the lower left corner. The 8 ball is at 3,15 over 4. The pocket she's aiming for is at 10,5. The ball is going to bank off the side at 6,0. Enter the equation for the path of the ball in this form. Alright. So we have 2 points that they've given us. We know where the 8 ball is, and we know what the vertex is. So let's start with our vertex. We have y equals A, absolute value, x minus h plus k. So this is the form that they wanted it. It's banking off the side at 6, 0, so right here, and that is our vertex. So we just plug in 6 and 0. So we have y equals A, absolute value, x minus 6 plus 0, but as you guys know, if you add 0 to something, it just goes away, so we'll leave that off. Now we have to get our a value. This time I'm going to do it the other way, the way that the textbook wants us to do it, just to give you guys a better feel for how it works. So let's go ahead and plug in the other value that they give us, which is 3 and 15 over 4. So we have 15 over 4 equals a times our x is 3 minus 6. Alright, so now we just need to solve for a. Well, 15 over 4 equals a, 3 minus 6 is negative 3, but the absolute value of negative 3 is just 3. So this is 15 over 4 equals 3a. Dividing each side by 3, this might be a little confusing if you don't remember it, but 15 over 4 divided by 3 is the same thing as 15 over 4 times 1 over 3. 4 times 3 is 12, so we have 15 over 12. Both of these are multiples of 3, so this becomes, dividing this by 3, we get 5. Dividing this by 3, we get 4. So a is 5/4. So we have 5 over 4 equals 5 over 4 times the absolute value of x minus 6. I did it again. Got myself outside of my absolute value side. Absolute value of x minus 6. That minus 6, remember, came from our h value up here. Okay, did the player make the shot? Complete the explanation. So what we need to do is we need to decide if the value 10.5 is on this line. Well, I'm going to show you guys a trick for how to do that. We're going to go to Desmos and we're going to plug in the equation for the graph that we just had. So let's go to Desmos. We had y equals 5 over 4 times the absolute value of x minus 6. And then we're going to use this graph to decide if the value that they were asking about, which in this case was, as you will recall, 10, 5, right here, is on that spot. So if I go to 10, here's 10, here's 5, and it looks like 10.5 is in fact on that line, because it is. The player did make the shot because the point 10.5 is on the graph of the equation. Alright, so that takes care of problem 13. On to number 14. We have Sam is sitting in a boat on a lake. She can get burned by the sunlight that hits her directly and by sunlight that reflects off the water. If the sunlight reflects off the water at point 40 and hits Sam at the point 5.5, 3, enter the function that describes the path of the sunlight in the standard form we've been using, then select the graph of the function. Round each value of the equation to 2 decimal places. Alright. I think I'm going to show you guys the Desmos way to do this problem, because I already taught you how to do linear regressions, but believe it or not, you can also do absolute value regressions. So This does require us to know the vertex. So if I go into table and I say my vertex is, so something that reflects off the water at 4, 0, and it hits her at 5.5, comma 3, then here's what we know. We know that y, let me see if this works, y sub 1 tilde a times absolute value of x sub 1 minus h close plus k. It does work. So what this tells us, if we come down to the parameters list, make this a little bigger, easier to see, you guys can copy, I said minus 4, that was supposed to say minus h. Okay, that did not work. So you are better off replacing this value with your horizontal and this with your so what you would want to do is you would want to replace this value with these two values with your vertex values, and then it will calculate a for you, which in this case is 2. So looks like we've got about that. So y equals 2 times the absolute value of x minus 4. And once again, it's plus 0. Check answer. That is correct. So humorously, they told us to round each value in the equation to 2 decimal places. That was why I actually decided to go with the Desmos method, because I didn't really want to sit here and calculate 2 decimal places by hand. So I went to Desmos to do the work for me, and it turned out that I didn't have to round anything. So we picked the graph that was at 4, 0 and had a opening of 2. Alright, last question. An office building is built in the shape of a 4-sided pyramid. It stands 800 feet tall. Okay, so a 4-sided pyramid, which means one side is going to look like a triangle. It stands 800 feet tall, so its height is 800, and 1,200 feet, 120 feet wide at its base. Imagine that a coordinate grid is placed over a side of the building. In the coordinate grid, each unit represents 1 foot. Enter an absolute value function whose graph is the V-shaped outline of the sides of the building. Take the left-hand corner of the building to be the origin of the coordinate grid, and express your answer using improper fractions in simplest form where needed. Enter the equation in the form that we've been using. Okay, so if this is 0, 0, then we know that this highest point is at, we know it's 800 feet tall, so this is at something 800. Something else that we know is that absolute value equations are completely symmetrical. So because of that, if this is 120 feet, then it must be 60 feet in the middle. So we know our vertex, and we know another point on the graph. That's enough for us to calculate everything. So our vertex is at 0, 0, and our other point is at 60, 800. So let's go ahead and vertex 0, 0, point is at 60, 800. So with that, y equals a times x minus h plus k. Y equals a times x. I'm sorry, that's not the vertex, that's the point. And our vertex was this. So h minus 60. K is 800. Now our other point was 0, 0. So we have 0 equals a times 0 minus 60 plus 800, keeping in mind where our absolute value sign was. So we have 0 equals a times the absolute value of negative 60 plus 800. Absolute value of negative 60 is just 60, so 0 equals 60a plus 800. Subtract 800 from both sides. Negative 800 equals 60a. And divide both sides by 60. Negative 800 over 60 equals a. But negative 800 over 60, we can take 1 0 off of each. That's negative 80 over 6. Divide both by 2, that's negative 40 over 3. 3 does not go into negative 40, so that's our simplest term. So we now have a, h, and k, so we can plug those into our equation. Y equals negative fraction 40 over 3 times the absolute value of x minus 60. Why does that keep doing that? Absolute value of x minus 60 plus 800 on the outside. There you go. That is everything you guys needed to do for section 2.1. That's your homework assignment. Hopefully you guys are going to be able to get through that without too many problems. If you do need any help, you guys know where to find me. Good luck.